In this video, we're going to go over naming simple compounds and writing their formulas. There are two main types of naming systems in early chemistry. There is a system that we use for ionic compounds, and there's a system that we use for covalent compounds. In the ionic naming system, you would name the first element its normal name, and add the term, remove the ending of the second element, and replace it with the ending "ide." In covalent naming, you're going to use prefixes: mono, di, tri, tetra, penta, hexa, and I'm assuming you're probably not going to go above that. Most of the questions that we've seen so far have only required ionic naming, but I wanted to give you the covalent naming just to be safe. So let's do some examples. If we have the element potassium chloride, we know that this is ionic because it starts with there is a metal first. So if the first element in the formula, which in this case is potassium, potassium is in the alkali metals group, so we know that it's a metal, then we're going to use the ionic naming system because it has a metal in front. So we're just going to name the first element its actual name, potassium, and then we're going to take the second element, which is chlorine, and we're going to remove that ending and replace it with IDE. So that would be potassium chloride, and that would be our name for that compound. So if we try another one, if we look at the first element, this one is strontium. It's in our alkaline earth metals group 2 on the periodic table. So we know that that's also going to be an ionic naming system. So we're going to use the name of the first element, strontium, and then we're going to write the name of the second element, phosphorus. We're going to get rid of its ending and replace it with an IDE. So that would be strontium phosphide, would be the name of this compound. The next example that we're going to do is going to be an example of a covalent compound. So if we have CO2, if we look at the first element, that is on the right-hand side of the periodic table, indicating that it's a non-metal. We're just, again, we're going to use prefixes. However, if it's the first element, we will not use the prefix mono and mono only. I'm going to name the first element carbon. And in covalent compounds, we're also going to do the "ide" ending. So if we have oxygen, we would take out that ending and replace it with IDE. So that would be carbon oxide, but we have to say how many of the oxygens there are. So we would use carbon di because di is the prefix for 2. If you remember, mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, and we won't go, I think we went to hexa, and hexa is 6. We're then going to put dioxide here at the end. And this is a common compound. I'm sure that you've heard of carbon dioxide before. There's also carbon monoxide, which is the same 2 elements, but instead of there being 2 oxygens in the compound, there's only 1, and that would be carbon monoxide. Let's do a compound where the first element doesn't have mono. in the name. So if we do P2O5, we're going to say diphosphorus and then pentoxide. And it's very common to change this vowel if there's a vowel at the end of the prefix and there's a vowel at the beginning of the second element's name, that you just use only one of the vowels instead of two. But since it's a multiple choice test, I doubt that they would have both forms of that on there, so it should be easy to pick which one is the correct one. If we're going to write formulas, then that is extremely simple for the covalent compounds because we're just looking for the numbers in the name. So for instance, if we had the compound named boron trifluoride, we would know that there's only one B for boron and for fluorine, because we have the prefix tri here, that's going to have a subscript of 3. A little more difficult is going to be compounds that are ionic, because then we have to use their charges to determine what the formula is going to be. So the rule is, in an ionic compound, the charges of all the ions have to add up to 0. So let's then say that we have magnesium fluoride. Magnesium, if we look at our periodic table, has a +2 charge. And fluoride, if we look at our periodic table, has a -1 charge. And if you don't remember how to determine the charges, you can either go back to the periodic table. You can go back to the periodic table review video, and it will show you how to determine what the charges of these elements are by looking at the periodic table. So in this case, in order for the charges to add up to 0, we're going to need more than one fluorine. And we don't add them, but we multiply. So we're just going to sit here and go, all right, if I have 1 times +2 plus x times -1 equals 0, what does my number x have to be? And that's going to be the subscript of my formula. So it would really be MgF2. And that would be the appropriate formula for this compound. Some compounds that are ionic will actually have what we call polyatomic ions in them. And polyatomic ions are a group of covalently bonded atoms whose structure has a charge. Most polyatomic ions are negatively charged. Some common polyatomic ions are hydroxide, acetate, nitrate, carbonate, sulfate, and phosphate. Naming these types of compounds, for instance, let's say that we had sodium sulfate, you simply, again, will be using the ionic naming system because we see that the sodium, it's a metal in front, and we'll simply name the first element. And the way that you name the polyatomic ion is simply by writing its name. So that would be sodium sulfate. So let's say that we were attempting to write the formula from the name for the compound aluminum carbonate. We would write its formula just like we would write the formula of any other ionic compound. So we would look for aluminum on the periodic table. We know aluminum is a metal, so we know we're going to be using the metallic naming, or that we've used the metallic naming system. If we look at the periodic table, aluminum forms a +3 charge. And we know from our information on the previous slide that carbonate has the formula CO3 minus 2. So in order for us to get a neutral compound, we're going to find the least common multiple of plus 3 and minus 2, which is 6. So that means that we would need 2 times plus 3 plus 3 minus 2's for our charges to cancel each other out, which will give us our formula of Al2CO3, and then we're going to put a parentheses here just so that we don't get this subscript confused with the 3 that we need to put there, 3. And that would be how you would write the formula for aluminum carbonate. Here are the review questions for this video. Please pause your video, answer the questions on your paper, and I will return in 10 seconds to discuss the answers. All right, if we're looking to name the compound MgSO4, we're going to look at that, and first off, it has more than 3 elements in it, so therefore it is a ionic compound. Plus, magnesium is on the left-hand side of the periodic table, indicating also that it's a metal. So we're going to write the name of the first element. Now, because this one has more than 3 elements in it, I know that it must have a polyatomic ion. So if I go back to my list of polyatomic ions, this one is sulfate. For number 2 says, write the formula for the compound calcium chloride. Calcium is again on the left-hand side of the periodic table, indicating that it's a metal. So we're going to use the ionic naming system. Well, if we were going to name it, but it's already named. So we're going to have to determine its charge, which you also only do when you've used the ionic naming system. So calcium forms the +2 charge. Chlorine forms a -1 charge. So in order for their charges to add up to 0, I'm going to have 1 times +2 plus x times -1 is going to equal 0. My x is going to have to be a 2. So I would have calcium CaCl2 would be my formula for this.